Hello.
How are you?
I'm well. How are you?
I'm fantastic. It's another shockingly beautiful day here in Western New York.
Yeah.
I've had to close all my blinds because it's the time of year when the sun starts shining directly into these things. And it just, the world needs to enjoy a well lit Clint, not a washed out Clint,
Evenly
right?
lit.
Yeah.
The
Yeah.
flattering light. That's
That's
important.
right. It's very important, especially when you start getting a bunch of wrinkles like I have. We have Curt with us today. Hello, Curt from
Hello,
Google.
Clint. Hello, Clint. Hello, Ken.
Hi.
So
Welcome back.
Curt is joining us as the what's your favorite term for the person who has contributed almost everything to BrowZer? The the
The
the
single ringable neck. I don't know.
I love it.
The
Fantastic.
guilty
So
party. The culpable entity.
There you
yeah,
go.
so we're gonna talk about some BrowZer today. That's why Curt is here. As is normal, here is the slide that I show every single week. 26.10 is still the current release, so I put a little strikeout through it today, so I don't have to go and remember to check the changelog like I often do. And then we're gonna just talk about BrowZer. And so this is a very free-form type of event. We have had a couple of blog posts that Curt has authored and put over on OpenZiti.io. If you haven't read them, you should go and check them out if you're interested. And so we've told the world that BrowZer is coming out of, I don't know, stealth or whatever, being released, however you want to come up with the term. It's in the last stages of landing the plane. I think that's a favorite of Curt's, is landing the plane. So it's coming out of being in development and going to be in use soon. So a bunch of blog posts have been being written. And so Curt, can you just tell us what would you, for somebody who doesn't have any idea of what BrowZer actually is, what is BrowZer? Oh, and do you have any visuals that you want to show? If you want, you can share your screen if you're interested. But yeah, what is BrowZer? Where'd Curt go? Curt clicked the wrong button. There it is. Let's
I'm a
put
newbie
Curt's
with
screen.
streaming
There we
software.
go. Let's do this.
Yeah, what I did was I just brought up the OpenZiti Tech blog, and I went to the BrowZer series. There's not a lot of articles there, just a couple, 2 or 3, 4. More will be coming in day weeks as we roll forward. The one that's probably most relevant today is this one that we pumped out a few weeks ago. And I'll make reference to a picture that's down here in a minute, but the big picture, to answer your question, Clint. So we talk a lot about Zitifications, app embedding, terms like that on this project. And most of that entails writing code in applications to use our SDKs to get on and off the network and move data around. So we asked ourselves quite a while ago, how would we do that for web applications? How would we do that without requiring the end user client out there on their mobile phone or their laptop sitting somewhere on the internet to install any software? Is that something that's possible? So we thought about it, and we invented this stack of components that we collectively refer to as BrowZer. So at the end of the day, it's a way to allow our users, our customers, to run a web server that is facilitating serving a web application to their users, hide it from the internet so that no malicious actors even know it's there, therefore can't attack it, but still make it easy for the end users to access it.
And I see. So if I can sum that up then in my simpleton way, OpenZiti all about zero trust and looking to keep your web applications safe. Usually, I think most people probably think web application, it must need to be public, right? How does it reconcile between classic web apps being thought of as public and changed over to this dark mindset, or where you're about to get into that?
Yeah, this picture is in the intro to BrowZer blog post, so folks want to refer to it after the fact. This is where this picture lives. I'm going to try to pull it up a little bit. Imagine, well, this was an example that I used running Guacamole, but this could be any web app, so don't be too concerned about this rendering Guacamole. The demo we'll do here in a few minutes, if we have time, we'll be using Mattermost. But the web app run always has, you just put it in your hosting center in such a way that there are no open ports coming to it. And then we kind of put Ziti in front of it.
So the idea is to take an app that we think of as being able to access publicly, but make it so that not just anybody can access it publicly. Is that the idea?
Right. There's a lot of componentry on this picture. But instead of the classic model where a browser comes through the internet and hits the web server, what's going on in this picture, top left is the browser. The first step in getting onto the Ziti network and gaining access to that protected web application is to come to this thing that we sometimes refer to as an HTTP agent. And in more recent blog posts, I've referred to it as the browser gateway. It is the surrogate, if you will. It's the front door to gaining access to that dark web app. One of the things that we have in place for kind of a step one authentication is a requirement to run an IDP, an identity provider. Which one is up to you. We list a couple of them on the page there, and they also federate out to Google Workspace, for example. And collectively, you can think of that as a single sign-on. So when you hit the browser gateway from your mobile phone or from your laptop, the HTTP agent, the browser gateway, will determine whether you've already gone through that SSO process or not. And if you have not, it just offboards, it redirects out to your chosen IDP, and you go through that logon process. The example we'll show in a minute, we'll use Google Workspace again. Once you get that, you have a question?
No, I was going to say, so a regular, I'm a enterprise user and I want to secure, I don't know, I always use the HR application, right? Because that's sensitive material. But if you were a doctor's office or something along those lines, and you had sensitive information that you didn't want anybody to like hack you, right? So we're trying to add extra security. This sounds like we'd need one of these Ziti HTTP agents that is defined out there. Does that agent, that is it receiving, like I must go to it first, right? So if I used to have an app that was public, like call it my.web.app, would I still go to my.web.app, or would I go to this thing and then something else happens? Like, do I come here first?
Yeah, well, you're absolutely spot on. The first step from the client side is to hit the gateway, the Ziti HTTP agent. It will have its own DNS name. So to answer your question about will it have the same DNS name as my.web.app, that's up to you. And it depends on whether you're using an open source, your own kind of deployment, or you're going to be using the Cloud Ziti orchestrated by NetFoundry approach. If it's orchestrated by us, and this is still slightly in the to be determined category in terms of exactly how the DNS name, the vanity URL will be constructed, but it will be something like web app dash customer network .netfoundry.io, something like that. So a slightly different name. But if you wanted to roll your own, you could put it under any DNS name that you wanted to.
I gotcha. So if I was like, an system administrator for a website that is HR or that medical app, I'd probably I don't know, I'd probably use the Cloud Ziti one just because then I don't have to install it. But if I wanted to install it, I could install Ziti HTTP agent and then give it my own the old name of the old server, like my.web.app. If I owned that, I could give it that name. And now my traffic, instead of going to my old web server first, it would go to the gateway first. And then I'm sure we'll figure out how it gets to the old server that I used to have.
Yes.
Because we're not there yet, I know. But yeah. All right.
Right. So yeah,
I see.
the questions are for the stage of the navigation through the diagram. But yeah, the HTTP agent or the browser gateway, it needs to be publicly addressable from some DNS name. And if you wanted it to be living on the same DNS name that you previously did before you made dark your web server, that's perfectly doable. In fact, so I was just to say, some of the other blog posts that you see in the BrowZer series talk about how to do exactly that.
And so the HTTP agent is then configured with an IDP, like it's shown, so that I can go to Google Auth or Auth0 or whatever my IDP is. So my user would log into like Google or Microsoft or Okta or whatever, and then that'll authorize them with the browser gateway. What is the browser gateway going to do then? How are we going to? I think it's a good time, right? I think now we've gotten authenticated to the new browser gateway. Now some magic's going to happen. It's got because that's still a public endpoint, right? So I don't have a dark web server yet.
That's correct. It's hanging out there on the wide open internet, and you cannot get to the next step, as in trying to get onto the control plane without going through the IDP auth first. I should probably stop for a moment and inform everyone that what's missing on this diagram is some legwork that needs to be done, some Ziti network administration that needs to be done up front to tell the Ziti control plane that there is an external JWT signer, aka an IDP, that this network knows about. And there's some different entities, if you will, inside the control plane that where you would configure the network about the external IDP. There's some auth policies, and you eventually tie identities to the auth policies. So that's how it works. I don't know if you want to go to that level of granularity today.
No, I don't think so. But I think it's interesting because I do see up there Ziti controller referenced. That's not the Ziti controller that you're talking about. I mean, it's the same Ziti controller, but that little line is not the configuring line, right? That's a different line.
Right. The configuration, the priming of the pump, if you will, the control plane aware the IDP is not drawn on this picture whatsoever.
Right.
But it's germane to this conversation because, well, I'll come back to it. So let's assume that we successfully authenticated to, in this picture's case, Google Workspace. So that is what winds up happening is an OAuth token, a bearer token, comes back to the HTTP agent. It's certified that at least step one of the authentication process has succeeded. So it then bootstraps things into the browser. You see ZBR and ZBSW called out in the browser side. That is the Ziti.
Where do you see those? Oh, in the Windows box there. I see. Thank you.
Yeah, in this browser. So those two entities collectively are the runtime, but there's kind of different granularity to them. So ZBR, Ziti browser runtime, and Ziti browser service worker are loaded dynamically into the browser by the HTTP agent, along with some additional configuration information up to and including that OAuth bearer token.
So if I can understand, then is this basically, so this is kind of like a shadow installation of the things that need to be in the browser's environment in order to like move forward? Is that what?
Their shadow, well, they come out of nowhere as far as the browser is concerned. I mean, you can literally start in a Chrome incognito tab, hit the HTTP agent, pass through the auth process, come back, and then that's where the magic starts happening on the browser client side. We load.
I see.
The runtimes and a little bit of configuration information, which includes how to find the Ziti controller. That's how we start talking to the control plane.
I see. So the gateway is going to configure my browser for me.
Sort of, yeah. It loads a small snippet, if you will, of HTML that then causes the browser to come back to the HTTP agent to load the various JS files that are the browser runtime and the service workload.
I see. I get it.
Some ancillary other pieces and some WASM. Let's make sure we talk about the WASM here in a minute also.
Very fancy.
And part of that configuration information, part of the bootstrapping of the runtime, once it reaches the browser, will entail reaching out on this top blue line. Again, the controller has publicly accessible client endpoints where you can try to authenticate to it. And there are at least 3, maybe more by now, different styles of authentication to the control plane. We are going to be using the style that leverages this external JWT that we got from the IDP. So we at that point, the browser runtime says, "Hey, controller, I want to authenticate with you so I can continue to bootstrap onto the network. Here are my credentials." We pass in that OAuth bearer token, aka a JWT, and that JWT has encoded within it a lot of information that we got from the IDP, who I am as the person who's logging on, and the controller examines all that information and says, "Do I even know about this external JWT or IDP? Do I know who this particular person is who says they're associated with that? Yes or no?" And the controller will either authenticate or not based on that. So
cool.
Running through that again, let's imagine that I have logged into Google Workspace with my non-NetFoundry Google credentials like Curt@gmail.com or something like that. I'll successfully authenticate to Google. I'll successfully get all the way back through the HTTP page of the browser. The browser will talk to the controller, and it's at that point the controller will say, "I don't know who Curt@gmail is," because they weren't pre-authenticated into the control plane, or pre-configured, I should say. Assuming you succeed at that point, that's when the rest of the PKI work starts to happen. So, as you know, in a Ziti network, everything's done with mutual TLS and a lot of X509 certificates. And most of the enrollment that we've seen in other environments doesn't happen through files that are passed around or commands that are run. It's all done automatically, and we refer to it as ephemerally when the browser is talking to the controller. So the WASM I mentioned before is used in a bunch of different ways. And by the way,
and what's WASM?
Yeah, sorry. WebAssembly. If I say WASM, WebAssembly, I'm referring to the same thing. And what we use a couple of different components that are based in WebAssembly. One of them is we've taken the OpenSSL C language library and cross-compiled that into WebAssembly. And the Ziti browser runtime uses that WebAssembly to do PKI work, such as generating a private public key pair.
Why didn't you just do it in JavaScript?
We did that initially in the first, I guess, instantiation of BrowZer. We did it in pure JavaScript, and we got it to work. It was just painfully slow. Just generating a private key pair, for example, depending on the numbers, which is part of the math that it does, it would sometimes take 3 seconds, sometimes take 3 minutes. And our users just wouldn't have patience for that.
I am certainly not that patient. 3 seconds is already pushing it.
Yeah, to put it in relative comparison, we can now generate an ECDSA key pair in the browser using JavaScript and this WebAssembly in about 3 milliseconds. So
that's faster.
Many orders of magnitude faster. So that was one of the reasons we invested in the heavy lift that was getting that WebAssembly taken care of. We also do CSR generation and a little bit of exchange with the controller using other REST APIs it has to finally get the certificate from the controller that we would use to get onto the Ziti network. Additionally, there's more communication that happens here between the ZBR and the controller to say, where are all the edge routers that my identity, whoever I logged into the IDP as, what edge routers can I use to get to this service that I know I want to find? And the service in this case is the dark web app. In the Ziti network, there will be a Ziti service that represents it. And if the identity that the control plane knows about has all of its attributes, its role attributes set up to facilitate access to it, then information about where the edge routers are is passed back, and then the ZBR starts the mutual TLS handshake with that edge router. I'll stop there in case there's questions at this point.
No, it sounds like now we're getting into just regular ZD type stuff, right?
Yeah.
So you've logged in to the IDP, the gateway, the BrowZer gateway delivered the runtime, the ZD browser runtime, the service worker. It talked to the controller. It verified the OAuth token given to us from the gateway, which was from the IDP, and all that would, and then generated a certificate on the fly right there in the WASM, all for the purpose of being able to connect to an edge router. And so now it's connecting to that edge router, and that's so that we can actually, someone's got a phone call.
Yeah,
And
sorry
so
about that.
that's so that we can dial from our browser to our private web server, right? Do I have all that right?
Yep, definitely.
Now, one thing I noticed here, though, is I see a WS binding and I see a different icon for the edge router. Why? What's up with the edge router there?
Mhm. Most of our edge routers from other SDKs accessing are listening to TLS. What we call the WS-enabled edge router has a new transport, a WebSocket, a secure WebSocket transport. And that is because we're coming in from the JavaScript runtime in the browser. So we need to connect to the edge router through that pipeline, if you will. So the edge router has been enhanced to not only have an additional transport that listens for incoming WebSocket connections, but also it's kind of a double stage thing. So you can come in and ask for a secure WebSocket to any of the edge routers that are out on the internet. Anybody can do that, but once you're connected, that's when the mutual TLS starts happening. So it's one of the reasons I have this silly diagram about an arrow within another circle, if you will. It's my approximation to tell you that there's actually two pipelines going on there. So let me say that again. The ZBR does what classic web applications do. It says, I want a new WebSocket, and here's the URL, WSS:// whatever the name of the edge router is. And the browser will make that connection and give it back to us. It's at that point over in the edge router side that it passes the responsibility to continue the connection to some new mutual TLS handshake code that we have. And the ZBR is now responsible for doing its own mutual TLS handshake. And most of the time, the browser is doing that work on behalf of the JavaScript that's running inside the browser. We can't use those typical mechanisms because doing so would require a certificate to be installed on the operating system where the browser was executing. And that was a pain point that we didn't want our users to endure. So we are using this ephemeral cert, which means the Ziti browser runtime in pure JavaScript in conjunction with that WASM is doing all the mutual TLS handshake at this point.
Is this WebSocket implementation using the feature of Chromium called Web Transport?
No, this is a classic WebSocket. It's
Okay.
just that
So it's not Chromium specific.
No, not this. Not this. Once the WebSocket is accepted by the edge router, then control comes back, and the HTTP 101 happens, and it gets the HTTP request gets upgraded to a WebSocket, and then the Ziti browser runtime will say, "Oh, now that we're actually talking to the edge router, let's do the mutual TLS handshake over that binary WebSocket." And all the work that is a TLS handshake, we can sidestep for the moment, but that's done again using the WebAssembly, the OpenSSL TLS mechanisms are being used by the Ziti browser runtime to do that, and we're ultimately using the ephemeral X509 cert that we got from the controller.
And the WebSocket the WebSocket router, is that just because is there easier facilities inside of the browser for WebSockets? Is that why it's specifically WebSocket, or was there another more interesting reason behind WebSocket as opposed to just a standard TCP listener type of thing?
I don't know how to answer the most concise way, but doing classic socket programming in a web world through WebSockets. So there's
That's what I figured. Yeah,
it's my short and sweet answer. At the end of the day, we're doing TLS. We're doing socket programming. It's just done over the type of pipe, if you will, that the browser knows.
That's what I thought. I didn't think there was anything else there. I thought I'd ask.
Yep.
So that takes it to a lower level, and it means that the bytes that are being transported don't have to be HTTP. They could be anything.
Oh, it's pure binary.
Yeah, WebSockets are binary. So it's the acquiring of the socket, which is what the WebSocket is interesting. You send a special upgrade header, and it treats the connection differently, and both sides know how to handle that. And once you're connected, like Curt's saying, it's just a byte pipe and bidirectional byte pipe, like a classic socket.
Right. And the mutual TLS handshake will succeed or fail. We'll for this example, we'll say it succeeded, and after that, once you're fully connected, then the next layer in the cake, communication-wise, starts to happen. And I don't know how much you've covered this in other ZDTVs, but the edge protocol, binaries about hellos and all that kind of stuff starts happening. So the Ziti browser runtime has with similar logic as say the CSDK does to do that. It's like, dear Mr. Edge Router, here I come, hello, and there's this back and forth, and eventually the data packets start getting sent. So that handshake upon handshake happens, and then it's after that back up in the browser where the Ziti browser runtime is executing. It in conjunction with the service worker has the responsibility to intercept any I/O that's going to the network, either from the DOM or from the JavaScript runtime itself. We kind of wrap that, look at everything that's going off board, determine whether the target of that network request is a wide open internet, Google Analytics or something like that. We'll just let that go to the raw internet. But if it's targeting this service that's down here, we grab it and we push it down through the edge router and have it go across the Ziti mesh, eventually terminating it out.
Before we get deeper into that logic, can I check up my understanding at the bird's eye view of a couple of things?
Mm-hmm.
So what I see here is that we are bootstrapping MTLS, which is kind of like a holy grail of security. We want to protect our application. This is a private web application that is intended to run in the browser. And what I'm seeing here is that the browser, before this bootstrapping occurs with the big purple arrows, doesn't actually have any kind of IP path even through a proxy to the web server. It's totally isolated. And we're at that first stage with the blue arrows, the horizontal arrows at the top of your screen. You're only talking to the identity provider, which is public anyway. Mm-hmm. And as soon as you have that authentication token, then you're able to bootstrap the mutual TLS with the ephemeral certificate. And at that point, you've got Ziti software, which was delivered into the browser, running in the the user's browser and connecting with mutual TLS to another piece that's on the internet, the Ziti router, and only then is there a path to the private web application.
You nailed, excuse me, you nailed it. I did my best to label with blues and reds and purples, and I think you followed it perfectly. It's important that the HTTP agent is live on the internet, listening to all comers. You won't get past it unless you have a successful auth from the IP. Go beyond that. The controller is listening, wide open for incoming HTTPS REST calls, not mutual TLS at that point, for whoever the client is to try to authenticate. And there's some complexity there that we've already covered. Once you get past that stage, you can ask the controller plane for the rest of the parts that are necessary, including that ephemeral cert.
Right.
And then the mutual TLS happens. I wanted to go back. I mentioned a moment ago there's two WASM components that are used by the ZBR. One is the OpenSSL, PKI and TLS, circuitry. Well, another piece, there's a reference down here at the bottom of the page. This end-to-end encryption, if you will. So other SDKs use libsodium to do their end-to-end encryption. So it's important to note that is in play here as well. We have taken libsodium, their WASM equivalent of that, and we have brought that into the ZBR world. So by default, when services are being set up on Ziti networks, they are enabled for end-to-end encryption. So in a browser world, not only are we using a secure WebSocket, and then within that, we're doing mutual TLS. Within that, we have encryption going on before we ever start talking to any of the mutual TLS or secure WebSocket stuff. So in effect, we're triply encrypted in a real world by default. You can always turn off that encryption if you want to, but the overhead of that is so slight that it doesn't make any sense to
Why
do so.
not leave it on?
Yeah, exactly.
So in the threat model, that would actually protect us against observation of the web application traffic at the intermediaries, such as the WebSocket binding, the terminating router, those things that you're only communicating with after successfully brokering mutual TLS. But even then, if they were compromised, they still don't have the ability to observe the traffic because it's end-to-end encrypted from the software running in the user's browser all the way to, well, I guess it's decrypted into clear text at the terminating router.
In our case,
it depends on if you're sending HTTP or HTTPS there too.
Right, exactly.
If it was HTTPS, then it would go all the way to the Tomcat server before it was decrypted.
Yeah.
But in that scenario, you're running TLS over the end-to-end encryption. Like it's the TLS is in the server TLS is inside the end-to-end encryption.
Yes,
it's like 3 layers.
It is. Yeah,
that's how regular Ziti works too. That is not particular to browser, but that's just regular Ziti.
Right.
Yeah.
It sounds like you can run pretty much anything inside of the browser. Can you run in a complete virtual machine inside the browser?
I haven't just tried it yet. There's some articles that are coming out related to that I need to investigate. I'm not equipped to tell you how close or how far away we are to doing that. But stay tuned for news on that.
There's can you, and then there's should you.
Yeah, we might should. I'll put it that way, depending on use case. I mean, the use case that we have in front of us here. Just pick your random web app that you want to make dark. I don't know if that new WASM-based VM is appropriate or applicable, or if this is the perfect solution for that. But until I dig into it, I just don't have what it takes to answer.
Yeah, I don't know if you thought about this yet, and I certainly can't answer this question, but I have to wonder if if we're comparing security threat model A to threat model B. Threat model A is how Ziti works today, and threat model B is how my Ziti network is postured against threats when I add the browser domain as a potential surface area. So take, for example, a compromised browser or a malicious extension running in the browser. Do I need to take into account that I'm opening myself up to browser-based attacks at that point? Like, is there a way for a malicious extension to steal that ephemeral certificate and use it in nefarious ways? Or is that the wrong question? Because if you have a compromised browser, all bets are off anyway.
Yeah, it might be the latter question. Without knowing more specifically what this malicious extension is and how it operates, I'll say we should be sandboxed away from that. If I didn't already mention it, the ephemeral certs are just that. They're just in memory. We're not writing them down into any browser local storage at all. If there's some extension that allows infiltration into the same runtime as we're discussing here, then maybe, but I still don't see it right now.
To be determined.
Yeah.
It certainly requires a very determined individual, regardless. Doesn't sound trivial to be able to even try to get in there.
Right.
Yeah, I just wondered if by adding the browser onto my stack as a potential point of intake, because today, in order to get onto the Ziti network, I need Ziti software running somewhere, and what this is doing is just delivering it into my browser. So it's some additional surface area in the form of the browser itself. That is, if something, all the classic attacks and perhaps novel attacks coming from extensions, they have I imagine they have some insight into the Ziti software running in the browser, but I don't know how isolated it might be because of this. I'm just really not that familiar with the WASM stuff.
Yeah, again, I'll assert that we're sandboxed until someone proves me otherwise.
Okay.
Two other things I wanted to call out before I forget. We're talking about, in this example, this diagram, one dark web app. The direction we're heading with the browser stack in general is to allow a single HTTP agent, a single browser gateway, to facilitate external access to multiple web apps. So, stay tuned. We can do another Ziti TV when the time is right on how that works and how to visualize and how to configure that. But it's not a one-to-one forever. It's one-to-one right now. But tomorrow, you could have your HR app and your administration console, all of your developers, Jenkins, it doesn't matter. You could have all of them kind of hanging out behind a single browser gateway with a single SSO to get them all. And depending on who you are, let's say you're an HR person, well, you would be able to access the HR app from an administration perspective, whereas Joe Developer, although coming through the same gateway, may not. But that's just by the power of the role attributes that Ziti brings to bear. And the other thing, since I'm looking at this picture and it's talking about guacamole down here, and a moment ago we talked about triple encryption, and oh my gosh, that sounds like a whole lot of overhead. Well, I had hoped to do a demo today using a guacamole server, but let me just say that RDP HTML5 canvas running in the browser listens to mouse moves and keyboard strokes and all the rest of that stuff. And you can imagine if there were a lot of performance overhead problems when someone moved their mouse across the screen on that remote Windows box that was being driven on the other side of the planet, now that could be a problem. But in spite of all the machinery that we have here, the performance of driving a Windows app over RDP, including mouse moves and keyboard strokes, it's almost no different than using it without the browser stack being there. So we're pretty happy about that.
And Curt, you've demonstrated that on a video, right? I believe I've seen one.
Yeah, it was published maybe 2 months ago-ish.
Yeah,
and it's out there on the OpenZiti YouTube channel.
Yeah.
If people want to find it.
Cool. Well, this Like it's been 40 minutes. I'm sure we could go forever on these things. Is there anything? It's a great overview. Thanks for providing it. Is there anything that you missed from the overview perspective that you thought would be useful for people to know or see?
Um, I don't know if it's overview about the technology and its underpinnings. I will take the opportunity to reach out to those who are listening either now or on playback. If what you saw is interesting and you want to talk to us about doing a pilot with you, we are interested in having a conversation because we are now at the stage, we've reached a milestone where things have stabilized. We have a number of web applications that are running quite well, but our goal is to say, the browser stack works with any web application. And right now, that's a nervous statement. Until we see it work,
What makes you nervous?
There's a million ways you can write a web app. There's a bunch of different platforms out there. There's a bunch of different frameworks. There's a bunch of different clouds. There's a million ways to trip up the Ziti browser runtime in ways that will cause it to not intercept traffic, for example.
Gotcha.
Or once I'm in there intermixed with the application and it's doing what it does at runtime, I might perturb it in ways that unexpected ways to basically break the application. So it's those types of things that we want to find sooner rather than later. So again, if there are people that have their favorite web app, whatever it is, and are interested in trying this out, we do not have GA capabilities. We cannot orchestrate all of this for you. Our Cloud Ziti offering, which is coming soon, but we can kind of
not yet, right?
Yeah, it's right around the corner. We're coming out with it pretty soon. And in the meanwhile, between now and then, we can do a partial network orchestration and then fill in the gaps, like we'll manually deploy the HTTP agent and configure it for you.
And now we have done that internally, right? Like we do have a demo to show. Shall we go over to that thing that you alluded to before?
You betcha.
I'm going to turn my camera off. And instead, I'm also can I share my screen and your screen at the same time? Does that work?
Sure you can.
I can. And so I'm going to do this. That makes it too small. Can you turn your camera off, Curt? And we'll do it in just browsers here with just audio.
I'm looking for
you can find it. There you go.
It's
right in the middle. Right in the middle, right there. Yep. That's the wrong one.
Other one.
You wanted to do the camera, not the screen.
Slightly different icons.
There we go. I will put that on the screen. There you go. And then pop over to your. Hey, all right, we're there. So I'm going to do it this way because I have the NetFoundry console or website up here. I can't make this bar bigger. I wanted to make my bar bigger, but I can go to browzercurt.ziti.netfoundry.io. I do that.
Web browser is actually talking to the browser gateway at this point.
Yes, and so my browser is on the right-hand side here, in case that wasn't obvious, and Curt is on the left-hand side there. And so I can, I've already authenticated through Google. Curt, maybe I'll just I'll make a brand new tab is what I'll do. Let's do this. We'll do it in, so I guess it doesn't matter if you got my password. Let me do the two-factor authentication stuff. Yes, it's me. Then we'll come back over here. And now I'm loading up the browser curt.ziti.netfoundry.io.
Yeah, these little blue toast messages that appear, this is for the benefit of those watching, are the ZBR and the ZBSW kind of announcing their presence. The runtime itself is supposed to be headless, invisible, doesn't really have a UI. It kind of does, I'll show you in a second, but this is a way to help people know that we are there and that we are operating properly.
And for anybody watching, these little toasts and any perceived delays at this point, that's all just because of the initial bootstrapping, right? Like
Mhm.
once it's bootstrapped, do you still have those kinds of delays?
No, most of the what we're going to move forward with in the demo now, you'll see that
I can't remember. It can't remember my settings for whatever, like Mattermost is not remembering me, it's remembering my browser. So I'm trying to get back to us. There we go. Apparently we've got some things to edit out of this video.
Fair enough. So I'm going to open up, or I'm going to actually switch function option 12. This is the UI set that really wasn't there. I'm going to set my client side tracing to be very loud, very chatty. Once my page reboots and that new tracing level is in effect, I will open up DevTools and watch the console chatter. And then you can just send a test message to that channel that we were testing.
I am trying to get there we go. How about that? I'm trying to make it so that it's actually legible on this screen here. So I see all your tracing happening. And so now you said I can send you a message? Like,
yeah, go ahead and send me something.
Hi there, Curt.
Okay, so I didn't move anything on my screen, but a whole bunch of chatter just happened. So let's scroll back and walk through that. So what happened was we got a message on the WebSocket that we talked about earlier, and we went through a bunch of WebSocket wrapper, decrypt, encrypt, back and forth and through the WASM, and eventually pushed that back up to the WebSocket that we intercepted from Mattermost, the web app we're using here, and gave it to the application so that I could see that. So if I did the same thing here and said, go back, basically the same thing happens in the opposite direction. We intercept all of the keystrokes and messages that the web application might have sent over to that WebSocket. We get it first in the Ziti browser runtime. We take a look at where it's going. We say, oh, look, it's headed for that service that is our Mattermost. And we do all the mutual TLS, encrypt, decrypt, interception stuff we talked about before. And you can see, even with this heavy amount of tracing, the amount of, speed, if you will, is really not there. So yeah, there's some loading delays for an app that's as big as Mattermost is. Some apps that aren't, well, let me stop there for a second. Mattermost is, 40, 50 megabytes of JavaScript and CSS and whatnot. And the current state of affairs in my WASM TLS, memory management between it and the JavaScript runtime isn't as speedy as I'd like. And that's part of what the loading overhead is. But once your app is up and you're just sending these tiny little messages, that overhead is, you can't feel it.
Very neat. So while Curt was talking there, Ken and I have been going back and forth a little bit in the chat, as people could probably see from Curt's screen, not my screen. And that's pretty cool. So I don't know, is there anything else that we want to show? I mean, that was BrowZer in action right there. I'm going to bring my video back on the screen. Boop, boop, beep. Where's the beep, boop, dee, boop, dee? Do this, do that. I don't know how to get myself back here. We got Curt. We'll take off Curt's screen share. Now it's just me and Ken. And so that was pretty neat. So I logged into BrowZermost and then sent Curt messages through my browser to a Mattermost server, which is protected by OpenZiti and dark to the entire internet. But using BrowZermost, we were able to get onto the overlay network, send traffic, see it show up basically immediately. Like Curt was showing, all the trace messaging didn't particularly make any impact that was observable. I mean, there was probably some CPU going on, but like the human doesn't care, right? And that was pretty neat. So I don't know if there's anything you want to close with, Curt, but the floor is yours.
Yeah, thanks for having me. One additional point, in addition to having people reach out to us if there's interest, I just wanted to also reemphasize that the dark web app itself was not modified. We did not Zitify it. We did not touch it. We are running stock Mattermost Enterprise Edition, self-hosted by us at NetFoundry in a completely unmodified way. So when I say the goal of BrowZer is to accept and run and be able to protect any web app, there's an example. You don't have to worry about doing any modifications, any instrumentation of your app whatsoever to make it work with the BrowZer stack. Same thing on the client side.
Could we use the same approach to run other types of apps? Like for example, Guacamole is a web app, right? So it's transporting an HTML5 canvas back to the user agent. But what if you ran an RDP client compiled to WASM inside the browser, and so your server wasn't HTTP but RDP?
Maybe this is going back into the direction that you went to before. So effectively, when you're running RDP in the browser, the thing that we intercept as the Ziti browser runtime are just WebSockets, and the software that's already there is capturing canvas events and throwing them over the WebSocket, which we have intercepted, and then we pump over our own WebSocket. If you're talking about WASM running in the browser, doing RDP and wanting to run things out over WebSocket, it probably will work as long as the intercept point is that WebSocket, because fundamentally that's what we're doing. We are intercepting WebSockets, fetch, and XHR. Those three primitives are what basically make web apps run in terms of a networking I/O perspective. So as long as what you described is doing that and not something outside of that, then we should be good to go.
Sounds cool.
Very awesome. Well, wonderful Ziti TV. Great introduction to BrowZer. Appreciate it. If anybody's interested, reach out to Curt and tell him I want to play. I want to get on the alpha, because I wouldn't even call it a beta yet, right? I'd say it's still alpha. And great. Thanks a lot, Curt. That's a wrap. We'll see you guys.
Thanks. See you guys.
Bye.